So welcome to the last talk of the conference. You made it. And I'm thrilled that you all chose me to be your last talk of the conference. So how about we get a big round of applause for all the other speakers? Because I've seen some amazing, smart people. And one more for the NDC team and volunteers who have kept this running pretty smoothly. Cool. So welcome to Vulnerabilities That Hide from Your Tools. My name is Jillian, and little intro about me. This was a while ago, but that was in Bali. I got to play with an elephant, and he was cute. But I am the founder and only employee of Gold Hat Security, and I started a company 3 years ago to do application security training. If you need any help with that, let me know. I've spent over 13 years in application security at this point, which makes me feel old now that I think about it. It's like, that's a long time. But I love to tell jokes. I used to do stand-up before the pandemic. I haven't done that in a while, but and I also love to travel. So I'm very excited. This is my first airplane trip in 2 years. So thank you for having me in Norway. So a little bit about me. So this particular slide, I didn't mean to copy the keynote from yesterday. Like, this slide is older than that. And it's just one of those great minds think alike things, I think. But just wanted to do like a quick overview of AppSec Tools and how long they've been around. It's not like super important, but I just wanted to kind of highlight the different kinds of tools. So starting off with static analysis, which is the one that I've probably worked with the most. Starting out with lint. This really is just a copy of the keynote. It's just, and then for a long time, static analysis tools weren't really looking for security vulnerabilities until we started discovering security vulnerabilities like SQL injection and cross-site scripting, kind of the era of MySpace. It started creating some new tools, so we got Coverity, Fortify, Checkmarks, and Veracode. So those are the static analysis tools, very exciting. Dynamic analysis is a whole nother category that's been around for probably a little less time and may or may not be as mature as static analysis tools, but you could argue with me about that if you want. It's almost happy hour, so we can go get a drink and we can argue about that. But Nessus, Metasploit, one of my favorites, Burp, Akinetics, and the like. Dynamic analysis tools. Slightly newer than that are the open source tools, so the ones that scan to see if your libraries have any vulnerabilities or if their dependencies have any vulnerabilities and such and such. My favorite of which is Black Duck, and they're not paying me to say that. White Source, another option, or Snyk, all very good companies. And then an even newer category of tools is IaaS, which is, I believe the I stands for interactive. Please tell me if I'm wrong, but I believe it's interactive application security testing. And I have not had the privilege of using any of those tools. So if anybody is watching this and wants to send me a free sample, I will check it out and be able to speak on that with a little more authority. All I know is it's new and it's a thing that you can use. So there you go. You can take pictures of that slide if you want. But okay, moving on. So I have kind of a little Venn diagram just with the first two types of static analysis and dynamic analysis and what they are good at finding. And yeah, so for static analysis, weak cryptographic algorithms and hashing, I have a little star that they're sort of good at finding those. They sort of just look for older algorithm names in the code. Hard-coded passwords, again, kind of good at finding those. Things like memory leaks and older sort of legacy vulnerabilities like buffer overflows, that kind of thing. Pretty good at those. They're both fairly good at the OWASP top 10. The OWASP top 10 gets a lot of attention, so tools are sort of geared towards finding those. Dynamic analysis is a little better at finding poor session management. And, oh no. Oh, that's fine. Just could be interesting. My laptop is apparently as tired as everybody else is. Just like, I'm trying not to move to make it angry. It's weird. Anyway, poor session management. Forgot what I was going to say about that, but that's fine. Missing security headers, always a popular topic for dynamic tools. Default passwords, so something like admin. A lot of dynamic tools will find stuff like that, but insecure server configuration. Yeah. So this is the stuff that I feel like they're pretty good at finding. Okay. Now, what they're not good at finding. This is by no means an exhaustive list. I kind of ran out of room on the slide, but I'll go through each one of these and just let you take your pictures and think. Okay. I'm going to start out with business logic flaws. Now, anything that's a business logic flaw, obviously your tools are not going to find unless you explicitly tell those tools to look for those things. And this is one of those things that as an application security person, I would encourage you to get to know whatever business you're working in. Talk to the people in charge, talk to the people doing the grunt work, get to know the business and how things should be working. And the more you can do that, the better you'll be able to find things like this. Some examples, just kind of really high level, but bad password reset logic. Any sort of password reset logic where a human is involved, you have to call an admin. That's going to be a vulnerability because we all know that humans are the weakest link. Poorly designed role-based access control. This is one that is a personal pet peeve of mine, but developers that have copies of production data. Does anybody else had to deal with that, or is it just me? You're all asleep, I can tell. Okay. All right, should we have a coffee break and everybody and just fight with my computer some more, and then you guys can go get coffee? And no. All right. I know it's the last talk of the whole conference, but we're almost there. So business logic is one category. Another thing that is going to hide from your tools is weak or reused passwords. Now, you can obviously enforce a certain amount of password strength, but it's very difficult to enforce users not reusing their passwords. There are lists of compromised passwords that you can download. I highly recommend it. Like if you really want to annoy your users, you can download a list of all the most popular compromised passwords, and then when they change their password, you can check that against that. It's an option, but somewhat there's some ethical issues there too, because where do you get that list from? From bad people, and sometimes you have to pay for it, so don't pay for it. Don't give them money. But anyway, so weak or reused passwords, very hard to control for. And the best thing you can do here is just try to encourage your users to use tools like a password manager. So I don't have any brilliant ideas right now about how to encourage them to do that. Just education, I suppose. But it's hard to control users. They're going to do dumb things. But I found this statistic that 75% of internet users admitted to reusing passwords across multiple sites. And I just want to point out that that is just the number that admitted to it. It's probably higher than that. Probably more like 95, 98, 100. I have a couple of reused passwords, but they're not for important things. But anyway, like I could admit to this. Don't fire me. Don't throw tomatoes. Nobody has tomatoes. Okay. Anyway, configuration whoopsies. This is a very broad category that can encompass many, many things. Just a couple of examples that are specific to AWS, and I apologize for that. But overly privileged IAM roles or default security groups. These are the sort of things that there are tools that you can add on that look for these sorts of things, but you have to tell them what to look for, kind of. So, trying to think of if I have any really terrible examples. And off the top of my head, no, but bullet points. Okay, we've got a lot to go through still. All right, is everybody awake? Okay, I'm gonna keep checking on you because you do seem a little tired, and I am too. I'm very jet lagged, but okay. Next up, denial of service vulnerabilities. This is one of those things that it's hard to even test for because like most pen tests, this is going to be out of scope. So if you are vulnerable to a denial of service attack, you don't find out until things crash, which is not great. But just some examples of the many, many ways that a denial of service can happen. Poor error handling, infinite loops. Those are really kind of hard to test for. Resource exhaustion is kind of an API thing, and it could also be a memory leak, but memory leaks tend to show up by static analysis. Anything that is going to destroy or corrupt data, that's a very broad category. Any single points of failure. User lockout is a type of denial of service. So if you have, for example, a rate limiting on incorrect password guesses, and it's a hard lockout, if that is an important account, like an admin account, that would be a type of denial of service. And deadlocks. So anyway. Another thing that's obviously going to hide from your tools is rogue developers or rogue employees of any kind, really. Not much you can do about that. This is a slightly older example, but in 2019, there were 3 Twitter employees that were actually charged with spying for Saudi Arabia. They were looking at protected tweets of political enemies of the state, if you will. So they were just using their privilege to report back to Saudi Arabia on what they were saying. So, are you paranoid yet? Okay. There's more. But wait, there's more. I'm like the ShamWow guy. But wait, there's more. Okay. Until stand-up is easier because in stand-up, you would all be in a club where there's a 2-drink minimum, and it's a lot easier to make you laugh. So I'm trying, but I know everybody's tired. Well, we'll get through this. A whole new category is cryptography disasters, which, again, encompasses many things. And I have some horror stories to tell about that. But anything that is a custom crypto, some clever developers who think that they're brilliant come up with a super secret cryptographic algorithm that they made up. No. Anything with ECB mode. Now that one, in the past, I have tweaked my tools to look for that, but they don't by default. So that would be a thing that you want to look for. Anytime you see an initialization vector that's hard-coded, that would be another thing that static analysis tools probably should pick up on, but I don't think they do by default. So I've also tweaked tools to do that. And then this last one is my favorite. And when we get to threat modeling, I'll tell you how I discovered this. But yes, base 64 as encryption. Yes. So I will tell you the rest of that story when we get to the slide about threat modeling. But that would be an example of a cryptography disaster. But he told me it was encrypted. Yes, sorry.
What is ECB?
Oh, ECB is electronic code book? Yes, thank you. Okay, it's the best way that I know how to describe it. There's a visualization, and if I wasn't so afraid of my computer crashing, I would Google it for you. But if you Google the Linux penguin with ECB mode, there's an example of that, the Linux penguin that's been encrypted using ECB mode. And basically, the way it works is that every time you encrypt a block in AES or any block algorithm, without a bit of randomness, the same plain text is going to end up as the same ciphertext, which makes it really easy to crack. So, and then but the visualization is the best way to show you that. So I will not be offended if you pull out your phone and give it a Google. Feel free. So, okay. Great question though. Are there any other questions before I continue on? Because I never know if I'm skipping over things too quickly, but okay, no. Are you still awake? Yes. Okay, just checking. It's almost nap time. Another category, and this is again very broad category, but I call layer 8 vulnerabilities, anything having to do with humans. That can cover a lot of things because humans are very creative in ways to break things. But some common examples would be anything having to do with phishing or social engineering, user error, and malicious insiders. I think we kind of covered lost laptops. And an example that I will not name names. I'm not going to say which one of my former employers did this. But an example of this was HR thought that they were being helpful and sending out a list of employees to certain privileged users to do a user access review every quarter. So, right, yay, security. However, they were sending way too much information. So it was a spreadsheet of all the employees, first and last name, which is what you need, and then their home address and phone number. I would not have been surprised if there was a social security number in there, which is the American top secret number that identifies you. And it's only 9 digits. It's not great. But they were sending out a lot of personal information to all of the people in this company, or not everybody, but the privileged users. And with that information, one of those privileged users got fired and then had a list of the home addresses of all the employees. And I'll let you use your imagination on how he misused that information. But that would be a case of user error. Just somebody thinking, oh, well, this is not a secret, and it should have been. So, okay. It's not a fun story, really. It's like, anyway, but another category, secrets in strange places. So I have seen some interesting stuff in the payload of a JWT token because people think that the JWT is encrypted when it's just obfuscated. It's not really encrypted. So if you're putting, sorry?
It's base 64.
Right, it's base 64 encrypted. Kind of the same sort of, yeah. That was not the same person that did so I guess it's a common mistake to think that base 64 is encryption. But text files, spreadsheets, config files, even sticky notes. You always have a password on a sticky note. Now, there was an admin password at a company that will not be named that just got passed around to whoever was in charge of the admin duties for the day. So anyway, those are the sorts of things that you're not going to find with tools. Now, false negatives is always a fun one. So I know static analysis tools get a lot of flack for the false positives it creates a lot of noise. You know, you've got more vulnerabilities in your tools than there really exist. But false negatives are also a thing. And I have a story that goes along with this example. So previous company that I worked for, they bought a software company in Brazil. Now, I ran their code through all of our tools, and it came back looking pretty good. I was like, wow, these guys are great programmers. Hardly any security vulnerabilities. Until I looked at the code, and I discovered that my static analysis tools were assuming that variables were named in English. So it was looking for things like password or key. And that's not how they had coded it. So it was hiding a lot of issues. So anyway, I tweaked the rules to look for contraseña, which is how you say it in Portuguese. Anyway. Sensitive data exposure, and I think that it's kind of a repeat category of secrets in strange places. But there's other ways that sensitive data exposure, it's a slightly different category. There's some overlap. Anyway. So examples would be things like error messages leaking too much information to the end user, secrets in the URL, and I've had people debate me on this one too. But anything that's a GET request, if you have secrets in the URL, I feel like that's a bad practice. Because it gets logged places, you know, in your browser history or whatever. Log files and data misclassification covers anything of, like, we don't all agree on what should be a secret and what's not. So, anyway. Insecure APIs. Now, if you went to Philippe's talk this morning, he did a great talk on insecure APIs, and he covered it. I don't really have anything to add to that. Yes, all of these things. If you missed it, I'll just go over very briefly. Any API endpoints that don't have authentication and authorization. Unmanaged or old APIs. Actually, I don't think he talked about that one, so I will expand. But if you have old APIs that nobody really knows how it works, and nobody really knows how to update it, and it's not really documented, but we can't turn it off because it'll break things, I'm going to classify that as an insecure API. So weak API keys, and I've also seen API keys just not validated. Just, oh, you have a token, you have the secret token, good job, and continue. So, not checking whether or not it's valid or expired or anything. So yeah, there's a million ways that APIs can go wrong, and I will refer you to Dr. Philippe because he's very smart. So next up, third-party integration flaws. Anytime you're integrating with any other third party, there's always things that can go wrong. So OAuth can be implemented incorrectly. That's not going to show up on a scanning tool necessarily. Any unencrypted connections to anything. Now, I do think that we are getting better at using encrypted connections, but I've still seen it in funny places. Just returning unfiltered API response to the end user. That is a bullet point that I wrote, and when I was reviewing my slides earlier today, I was like, I do not know what I was thinking of when I wrote that bullet point. But there was a specific example in my brain when I wrote the bullet point down, but it was years ago now. So I believe that it was like a React web app where it was calling an API and just returning the whole API response to the end user, I think. But don't quote me on that. I don't know anyway. And then lastly, just anytime you're trusting data from a third party without validating. Yeah, so, whew, we did it. We got through all of those. So I'm just gonna check and make sure that nobody's napping. No napping, okay. So, yesterday's talk, I don't know how many of you were there, but that was all about making your job easier. And today is all about making your job harder, and I do apologize for that. It's just somebody had to bring it up. So the point here is don't rely on your tools, right? So just because the tools did not find anything doesn't mean you're secure. I think I made the point. Okay, so how to find these sorts of things. There's the hard way. So pen testing, if you have a really good pen tester, they will find a lot of this stuff, not all of it. The other option is something that I spent years doing, which is manual code review. And I love that his face, because that's my face most of the time when I am reviewing code. Like, what? Huh? Now, I will tell you that if your full-time job is reviewing other people's code looking for security issues, plan on a vacation, because that's a tough job. It's a really you're just going to need a really long vacation, at least once a year. Probably. You know what, though? Now that I say this may be an American thing to just not take vacation. Is this an us problem? Yeah, you guys get whole months off. And would anybody adopt me? Because I would love that. If anybody knows of any jobs over here with 5 weeks of vacation, I would, yeah. I'm Happy to come. Anyway, so slightly easier way. Have suggestions. So there's the traditional approach of pen testing and code review. The slightly easier way, what I call the Lord Varus approach. And I realize that this is a slightly dated reference now, and Game of Thrones, everybody's blocked it out because the last season was awful. So I do apologize, but it's still kind of the best way to reference my best approach to a security. I'm losing my words. I'm blaming jet lag. Let me try again. My approach to security is what I call the Lord Varus approach. So Lord Varus, if you don't remember, if you've blocked it out because the last season was terrible, so he had his little birds everywhere, which were little kids, and we've got a debate about child labor now. But the point was that all his little birds told him things. So he always knew exactly what was going on in the kingdom because all the little birds told him things. And that's the approach that I like to take to security. Because at previous employer will remain unnamed, I was outnumbered at a ratio of about 1 to 500. I was 1 AppSec person to 500 engineers. And this was the most, that was the best I could do at the time, until we hired more people, was to just recruit spies and have them tell me what was going on. So there's a little bit of trust and rapport building that goes on with that. But if you missed my talk yesterday, I do have, that was the subject of yesterday's talk. And if you don't trust QR codes, I also put the link in the Slack for room 1. But I wrote a little 6-page ebook about how to set this up. And if you have any questions, let me know. But Lord Varus approach. Next, the rest of the story about the base 64 encryption. It comes on this slide. Okay, so threat modeling. Threat modeling I think it's a lot of fun. It's definitely better than looking at code all day. But basically, you get everybody in a room that knows how the thing works. Hopefully there's a diagram in there somewhere, or a whiteboard or something. And then at that point, the threat modeling is really kind of an art form of asking open-ended questions. So instead of, is this connection encrypted? Or is this thing, whatever it is, encrypted? Because if you ask that question, they're going to tell you yes, right? So this is a better question. How is this connection secured? And then they have to give you details. And if they don't know the details, that's a warning sign, right? So, or better yet, this is the question that led me to base 64 encryption. So where is the encryption key stored? If they can't answer that question, there's a problem. And that was how we discovered base 64 encryption. Oh, there's no encryption key. What? Are you sure? Then how are you encrypting it? Oh, base 64. Okay. So we fixed it, don't worry. So another example. So instead of do you have any sensitive data in the database, their answer for that is going to be no. You want to ask things like, what data is stored in this database? Or could you maybe just email me the schema? So, make sense? Cool. All right, now this is a term that I think I made up. So, the full circle development lifecycle. So you have all these tools, and we have now other methods of finding vulnerabilities, and you need a way of managing the vulnerabilities, and hopefully it's all in the same place, but it probably isn't because you're busy. I know, but here's a suggestion I think that will eventually make your life a lot easier if you continue to do it. So using all of the feedback from all of those tools and threat modeling and internal bug bounties, if you were there yesterday, you want to just use that and create a unit test for every vulnerability. So find a new bug, fix the bug, write a new test case, write some new code, deploy said code, and run the unit test. That's not on there, but it's assumed, and then you'll find more bugs. So you use I'm Sorry, the jet lag is really hitting me. So when you use all of the vulnerabilities you find and then automate finding them in the future, that's the whole idea. But I found that a lot of people don't do that, so I'm bringing it up. So, okay, we're almost done. You're almost to the weekend. Wait, it's not quite the weekend, but you're almost to being done with all of this learning. Okay, so there's a phrase that escapes my brain right now, but I think it's like an ounce of prevention is worth a pound of cure. Is that it? Okay, is that Shakespeare? I don't know where that came from. It's like I don't know who said that. That sounds like Shakespeare. Anyway, so education is going to be worth your time and money just upfront. Anything that you can do to teach your engineers not to do the things like base64 encryption, for example. Now, with education, the really important thing here is to make it fun because they might fall asleep. Like, I'm trying, I really am. And another thing is to spread it out. So it's really best in small amounts. So if you can do an hour at a time, like do one vulnerability at a time instead of making them sit in a classroom for 4 days or whatever, it's going to be more effective. Another thing that I didn't even put on here, but is to make it immediately applicable to their jobs. So if you find a vulnerability, much like the last slide with the full circle, so every time you write a new unit test, you can also write a new training program. And then you can actually use the examples from the code or whatever that you found from like an actual real vulnerability in your code and say, look, we found this. This is in our code, and this is how we fixed it. And then that makes it more immediately applicable, and they're more likely to pay attention to you. Yes, that needs to be a bullet point. So anyway, lastly, make sure it covers more than just the OWASP top 10. There are more than 10 vulnerabilities. So, secure default configs. This is just something that kind of helps with testing environments, but if you can use template configurations. I know I've had a lot of engineers just spin up testing environments with production data that are not secured at all. Take that ability away from them. So, this is one of those things that's going to fix a lot of the rogue developer issues, but background checks, always good. And there are services that I don't consult with your legal representative, but you can do a little bit more than just a criminal history and credit score. But I don't know how legal that is. It probably depends on country. I'm not sure. Don't ask me. I'm not a lawyer. Huh?
You're using Spies.
Spice.
In your organization, you have those birds.
Oh,
Yeah.
yes.
Yeah.
Well, we want to vet the spies first. Yes, make sure that they're. That's actually a really important part of being a spy, is making sure you're going to be loyal to whoever you're spying for. Yeah. Lastly is try to make it easier on your developers and centralize your security functionality. Yes, just write the code once and make sure that all of that centralized code is secure. Test it one time and make everybody use that, and that will help a lot. So I think I've used 35 minutes, not quite an hour, but I can tell that you're tired. So I'm being merciful, but does anybody, we can open it up to questions now? Yeah. I'm sorry, I will repeat the question so you don't have to run around with the microphone. Okay. But does anybody have any questions or comments or like things I should add to this that I might have forgotten stuff. I don't know. No questions? Okay, yes.
Have you actually run into ECB being used in sensitive encryption?
Have I run into it?
Yeah.
Have I run into ECB? Yeah, yes, I have. That's why it's on the slides. This is my life story. Yeah. Yes?
How do you introduce threat modeling to a development team? Are they
That's a good question. The question was, how do you introduce threat modeling to a development group, and are they on board immediately? It depends is the answer to that. Some of the groups that I've worked with have been very much on board with any of the security measures that I wanted to put into place, and some are very resistant to it. And that depends on the person that you're dealing with. But it's one of those things that it's very much, I feel like threat modeling has the most value at the beginning of the life cycle. And oftentimes when they're coming to you at the end, it's a much harder sell at the end of the life cycle, because you're going to review the architecture of the whole thing, and nobody wants to change all of that after they've already done all the work. So that's maybe where the spies come in. But whenever somebody's working on something new, say, hey, let's do a threat model before you get too far on that. Let me save you some work. And I know that a lot of engineers and people in general view security as an impediment to progress. And one of the things that I would like to convince people of is it's actually not, it's an investment. So you're investing some time up front to review the architecture and all that. But then it's going to be more stable, and it's going to work better, and just generally be better code because we put that effort in up front. So there's going to be a lot less like last minute things to add before launch, you know? So I try to sell it as like, let me actually save you some work. So does that make sense? I don't know. I'm also open to suggestions if somebody else has been successful at that. Yes?
More a comment on the the bad or weak passwords, the phone passwords list. That should be quite good to integrate against.
The pwned passwords list?
Yeah, it's like the have I been pwned, Troy-Con.
Yes. And I think just the behind the scenes where they get their passwords from is some of those may be from nefarious sources, but I'm not sure. Yeah.
All the breaches that
Yeah.
that shared.
Have they made that list public, or is it just you have to enter your like?
Like the list itself, it's only the hashes of the passwords.
Okay.
And like there's all the sort of the security model behind it, that even if you use the online version, it's not the full hash.
Mm-hmm. See, I think there are lists out there that the hashes have been cracked, and so you could compare a new password to that. But again, like check with your lawyer. Just.
No, it's more like when the user registers or changes passwords, you can send the hash of the password or check it against the list.
Well, that only really works if you're hashing without a salt.
No, as in like when you are processing the clear text password before like hashing and salting it. Like then check it against the list.
A list of hashes, though?
Yeah, like
Right, but if you're salting it, then you're going to get a different hash for the same
no,
password.
Like the list is non-salted. It's just a list of
Right.
passwords that
So if
you
you're
found.
storing passwords incorrectly, then you can use that list.
No, nothing about the storage.
Okay.
Like when you are first saving the password to your database and before hashing it, checking it against this service.
Okay. But so if I'm not really clear on how that works, because if your service is a list of hashed passwords,
Oh, like,
or
no, so you can't do this on the stored password. I wasn't referring to that.
oh, I'm totally confused. I'm sorry. I'm tired too, so it's not really making sense. But
So it's like when the user is on the registration form, types in the password, send it to your service, and then you can check it against this list because it's just a list of like password hashes, but just SHA-1.
oh, so you could do SHA-1 and compare it.
Yeah,
Okay,
yeah.
that makes sense. I gotcha. But don't store them like that, though.
No.
Okay. Okay, I gotcha.
And like lots of governments and services have integrated it.
Okay. And so, but where do you know where to find that resource off the top of your head, Or
Just like Google pwned passwords, or
Okay.
like have I been pwned, or
I know of Have I Been Pwned, but I didn't know that they had a list available. Okay, but thank you. Okay, sorry about that. Brain not quite work good. I'm smart, I swear.
long conference.
Huh?
Long conference.
It is. And it's the middle of the night for me right now. I should be sleeping. Just, okay, anything else? Or? I vote for happy hour. How about you guys? Time for happy hour? All right, well, thank you so much for spending your time with me. Okay.